So, hello friends, welcome back. Yesterday we have learned what is potential, that is electrostatic potential. We have also learned what is electrostatic potential energy. Today we will be learning what is potential difference. Okay, so today we will be learning what is potential difference. You denote it as delta V, where V is the potential. You already know what is V, right? Like, say for example, there is some electric field. Before I had explained you using a charge Q, but I am hiding that charge right now because you already know how to understand that. So I am only considering some electric field. What is V potential? It is the work that you do to bring a unit positive charge Q naught from infinity to some point. Let us say this point. Let us say this point P. Okay. Now today's lesson is about potential difference. Right? What is the meaning of potential difference? Let me pick any 2 points. Okay. Let me say this is point A. This is point B. Okay. If you have understood what is potential, tell me what is the potential at point A. What is it? It is the amount of work that you do to bring a unit positive charge Q naught from infinity to this point. Let me call that as VA. Okay. And what is potential at point B? That is the work that you do to bring a unit positive charge Q naught from infinity to this point B. Let me denote that as VB. Alright. Now, yesterday you have also learned what is the work that you have done to bring it from A to B. It is, I am calling that as WAB. Okay. Now, what is the charge that you are bringing? Let me write Q naught over here. What's the charge you are bringing? It is Q naught or Q, any charge Q. Okay. Now, the unit positive charge Q naught. So, WAB divided by Q naught. Now, since you are bringing it from A to B, I can write it as VB minus VA, which is equal to the work that you do to bring Q naught from A to B. From here to here you are bringing. Okay. So, that is nothing but the change in potential difference. The change in potential or potential difference, delta V. Okay. So, how can you write delta V now? Delta V is VB minus VA. Now, many students come across this statement and they'll have a doubt. Can I say VA minus VB and can I write it as WBA? Well, I can write that, but the convention is like this. So when I am bringing it, doing work from A to B, I am writing it as WAB. But then since the final point is B, I am taking that point first and then A afterwards. So VB minus VA will be WAB divided by Q naught, where Q naught is the unit positive charge. So Q naught is unit positive charge. Okay. So this is the thing. Now what will be the potential change in potential energy that you have already learned yesterday, right? So delta U will be equal to Q naught into delta V. This is equal to WAB. Yesterday we learned, like in the previous video you learned, that the work that you do in bringing Q naught from one place to another place, that work is being stored as potential energy of that charge, right? So delta U is WAB, which is also equal to Q naught into delta V. Now what is the SI unit of this? What is the SI unit of change in potential or potential difference? SI unit is joules per coulomb, or it is also called as volt. It is same as potential. Potential has a SI unit of joules per coulomb, right? So this just you are taking the difference. You are just taking the difference of potential. So it is again joules per coulomb, or you can also call it as volt. For both potential and potential difference, SI unit is joules per coulomb or volt. Alright, I hope you understood this. Now let us do a very small problem based on this concept. I hope you understood. Let me clear this up. So the question goes something like this. If 100 joules of work has to be done in moving 4 coulomb of charge from a place where potential is, I'll write potential like this, POT is potential. Potential is minus 10 volt to another place where potential is V volt. Find V. You have to find the value of this V. Okay. So, how do we find the solution for this? Write down what all is given first. Here, what is the work that you have done? WAB is 100 joules. What is the charge that you are taking? Q naught, which is 4 coulomb. What is potential at one of the points? So this is work, this is the charge. At one of the points, what is the potential? You have to include along with the sign. So it is minus 10 volt. So VA will be minus 10 volt. So you are moving it from this to this. So VB is V, which is what you have to find out. Okay, you already know what is the formula, right? So VB minus VA will be equal to WAB divided by Q naught. Okay, so if you take, okay, let me write it here. So, okay, V minus of minus 10. Please be careful, minus is there, minus in bracket again minus 10, which is equal to 100 joules divided by 4 coulomb. This is right. So when you solve this equation, you will get V as 15 volt. Okay. So at point B, what is the potential at that point? That is 15 volt. Okay. I hope you understood this. If you have any doubts or if you want to ask me any problems, please do comment below the video. Alright, thank you.